Okay, this is going to be part 3 of this video, and in today's video it's going to be a little bit shorter. I'm going to continue where I left off with the development part. Today we're going to talk a little bit about coding and data structures that we're going to use in this. Okay, so let's jump over and take a look kind of where we left off. So we were building that user interface up. This was the result as well of us starting our solution overview, the sort of journal of our design process in our solution. Yes, there was this section on doing it in sort of, we thought about what would it look like if we just did it in sort of just prompts on the screen. We then looked at what would it be like if we did it in dialog boxes. And then we said, well, what if we did it as a user interface? And we started to build that up as an idea. What would a user interface look like? And this was all documented as well. So this was documented in our, just minimize things for a second. In our internal assessment now, we have a, not only our section A, but a section B now, which is that process. And we built an appendix to kind of reduce our word count. So I'm going to open up section B, and I'm going to open up section A and the appendix. I'm going to open all 3 of those up. We also have our actual project now underway, where not only do we have a main Java file, a main class with the main method, but we actually built some user interfaces using the NetBeans Visual Designer to help us speed up the process. And we even found a little graphic to add to it, just to add a little flair to it. All right, so let's see what we got here. So our section A we wrote in part 1 of this video, outlines the problem. Our section B, record of tasks, is an ongoing process where we started drawing some sketches of potential user interfaces. Our appendix has those sketches in it, so from the prompts to the dialog boxes to the actual user interfaces that we've developed. So we then also included some feedback from our potential user who wanted more of a user interface than just the dialogues, so that is where we sketched that out. Okay, so today in our design process, I think I'm going to add to this little journal that today, so it's not March 20th anymore at all. That was kind of me doing that. Today, let's say it's March the 21st. Okay, we began examining data structures for the solution using a UML diagram. So that's where I'm going to go with this. I want to kind of make a UML diagram to kind of examine how this will go down, right? Okay, so building a UML diagram is one potential way to do it. We certainly could sketch it out the way we sketched out this thing here. We could sketch it out that way, but I want to try and optimize our timeline a little bit, so we'll try and do a more efficient way of doing it. Now, this is going to be, now obviously we're getting into coding. So the section C, 12 marks out of the 34, the largest percentage of the IB mark for the internal assessment, is really examination of the code in your solution. So it could be marked by your marker from the code alone, but I would definitely recommend some written portions that help highlight these important parts that you can do not only in the written section, but also a little bit in the video. That'll come later. You want to show off the coding structures that you're going to be doing. So this will also be part of our part B as we journal our process of getting to these data structures. This will also influence the markers to give you those higher marks. Okay, so a couple more points about code here since we're in the code section, right? I definitely suggest a written section, okay? It could be marked from the code alone. Again, with code, you can use images, so it's not going to count on your word count. You definitely want to show off all the cool code things and all that high-level code, and I'll show you why when we get to the marking in a second. As it says here, if you used any code off the internet, okay, please essentially cite your source by putting a comment in your code. There is no formal way to do this, but please kind of look at that. And if you want, I can show you an article I wrote on plagiarism in computer science to give you some ideas on how to do that. Okay? All right. Now, how is the difference between a 5.8 and a 9 to 12. And that's a pretty big range to think that you could get as low as 5 and as high as 12 on this section in terms of points, right? That's a big scale difference. That's a 7-point slide, right? So here's what we don't want. We don't want to have a moderate level of complexity. What we want is a high level of complexity in our code. So what does that mean? Well, unfortunately, it's not well defined. But we want our marker to think that the complexity of our code is high, not moderate. Okay? So we don't want them to say that they used some appropriate tools. We want to have them say that they are appropriate tools. Now again, what do they mean by tools? Do they mean NetBeans? No, I think what this part, because it's specifically about code, means is you're using techniques that are available to you. So for example, search algorithms, sort algorithms, data structures like advanced data structures or ADTs, maybe even arrays, maybe multi-dimensional arrays, that you're using appropriate tools for your solution, okay? You also don't want them to say there's some attempt to explain these techniques. You don't want to just try to explain them with some. You want to have an adequate technique explained to them. So that's what we're shooting for. We want that high level, right? We want appropriate tools that are adequate. That will more influence our marker to give us those 12 mark or at least the 9 and not mark us in this zone here. Okay, that's what we're shooting for. Okay, so that's our code. Well, we're not going to get to all of that today. Just sort of showing you what is kind of expected there. All right, so we're going to talk data structures now. We've got already some classes here. We're going to build more. So I'm going to make a package, okay, just called data, that will contain all my data structures. In other words, the classes I'm going to build for this. Okay, it's obviously an empty package now. So now I think I'm going to do is I want to make a UML diagram. And I want to do this online. So there's lots of different tools that I could use for this. I think I'm going to go with the first one, this lucid chart. And you can see right here, make a UML diagram comes up right away. Now, yeah, a lot of these you need to sign up and they might send you emails. So I can understand if you don't want to do that. That's completely fine. You don't have to do a UML diagram. Okay, it's not a requirement. So I'm not going to do this. I'm going to just make a student. So I've already logged into this. So I'll just log out and let's just try this again. Let's log in just to my Google account. And yeah, I'm going to make a new chart from a template. And I'm going to search for UML. And I got some options here, right? So I'm going to use a UML class diagram. And I'll just use this template. Why I'm using the template, it just lines up the tools for me, right? Okay. And yeah, with these free things, you get limits and stuff like that. But I think this should be sufficient for what I'm going to build here. What kind of a thing I'm going to build. All right, so you can see here, I don't want the premium. I've got some little UML tools I can use over here. For example, adding classes. This template showed me some of the stuff that I can use for UML. No, you don't need to know all the details of this. And no, you don't have to do it of a certain. Anyways, I'm just going to select all this stuff and start from scratch. There we go. So I'm going to start with a class. Let me zoom in. That class will be for when I store a note. Okay, so when I store a note for my note-taking program, let me think about the attributes I'm going to need for that. So one of the attributes or one of the properties of this class would be that the note would have a title. What type would that be? It'll probably be a string. Okay, the little plus sign would indicate that it's public so that I could access it outside the class. I actually think I'm going to make it private. Okay, I'm going to make a date. Oops, this thing isn't helping me. Let's try that again. A date, also a string, and what else? The content. Maybe that one I'll make public. Content. also a string. So those would be the things that this note stores. Stores the title, the date. Then what I can do is I can use the bottom half to think about methods, right? So I think I'm going to make accessor methods for this. I'm going to make a get title method, no parameters, and it returns a string, okay? I'm going to make a get date method that returns a string. So this is, again, me thinking through some of the code at this point. Do I need to go into all this detail? No, I'm just going to start with this at the note level. So get the date. Since the content is public, maybe I don't need to do that. Maybe this will change as I actually start coding, but for now I'm going to go with that. I'm going to make a constructor, a note constructor that takes the title and the date as part of its construction, okay? Maybe I also make another note constructor that takes all three, including the content. Okay, so I have that constructor. Maybe I make a default constructor that has no parameters. I don't know. These are my thoughts right now for what is going to be my note class. That's what a note will be for me. There we go. So that's what the note would look like. Then maybe I have a class of all the notes, a notes class, or all notes, or something like that. I'll just keep it simple and just call it notes. Okay, so what would it have? Well, for this, I think I'm going to have a linked list, an abstract data type that I'll just call my list of notes, right? A linked list type note. So I'm kind of thinking ahead here of what I'm going to have in the notes. What operations would I need, right, for this collection of notes? Well, obviously I would need to add a note. So maybe I'll make a little add method that takes a note as a parameter. And maybe it does return something, a Boolean, true or false. Was it successful? What else would notes need to do? Well, if I add notes, I need to remove a note. But removing a note, I'm going to base it on an index, right? Like a number. And when I remove it, maybe it would return the note itself. Maybe I want to get all the notes. That would be a method I have. And maybe it returns a note array, an array of note objects. Oops, I'll make that a public method. Okay, so I'm starting to think through my method development here by using the UML diagram. And hopefully this is being recorded so you can see that in action. Okay, what else? Maybe I can use this to get just one note. If I get one note, I would need an index number to get it. Like, give me the note, or no, yeah, I could do that. Ah. Index, integer, and it would just be one note. Why can't I spell today? One note. Or maybe I'll just call it get note, one note. Get all the notes, get one note, okay? What else would I need? Oh, searching. I would search the notes for a title. So if I give it a title object as a string, it would return all the notes that have that title. So again, I'm going to return it as a note array. Because it could be more than one, could be. So I'm just thinking that through. And if I search by title, I could also make one that I search by date the same way. And then maybe just one there where I search by text. And it gives me all the notes. So that gives me a lot of search options. Search by title, search by date, search by text. I could make some sort methods. Sort by title. That wouldn't really need to return anything. And sort by date. So two different sort options. And this actually is part of our planning. If we actually look back in our planning, we kind of thought that through a little bit. Okay, so that would be a way I could express all the notes, a way that that could work. Now, obviously, there's going to be a connection between these classes. The note class is going to use, or sorry, the notes class is going to use the note class. So I can connect these using an arrow. Now I have to decide what type of arrow. It's a usage connection, right? So again, if you forget a little bit about the UML diagram, what do the symbols mean? Right? We could look up some references, right? Some basic notations for what a UML diagram does, right? You can see here, it's kind of the way I laid it out here. And there's more and more sort of things we can get into. But let me UML diagram arrows, right? How the arrow types mean, right? What are the relationships? What is an association? What is an aggregation? What is a composition? What is a dependency? What is a multiplicity? What is inheritance, et cetera, et cetera, et cetera. So there's different ways you can express this. I'm just going to keep it pretty simple. Okay, I'm going to keep it pretty simple. So I'm just going to go with inheritance when one class is another, and usage, one class uses another, right? Which is essentially composition or aggregation, right? Or direct association, you can see there. So anyways, what I've done here is I have created the right type of arrowhead, except I want it to be a dotted line. So I'm going to just sort of switch that there. So you can see there, it's a dotted line connection between the notes class. Maybe I'll make this arrowhead a little bit thicker. And actually, maybe, can I do all of them at once? That would be pretty cool. There we go. And the note class. So the notes class uses the note class. But I also see it's going to be using a linked list class. So I'm going to drag over a class that I'm going to make called linked list. Now the good news about this one is this should already be done. If you did this in my class, you have a linked list class. So I could spend the time laying out all that stuff, but I really don't need to. And in addition to the linked list class, the linked list class uses a node class. And there's a connection, right? The node class uses that class. So I'm just going to once again use the same notation. And this class uses linked list. Same notation. So there we go. We have a note used by notes, which uses a linked list, which uses a node. Okay? So we're getting sort of an idea of the connection of our data structures at this point. Getting an idea. Now, obviously, we're going to have our user interface. We have some data structures we already have, right? We have our main user interface. I'll just eliminate all the properties and methods for now. So our main user interface. We have our, what did we call it? Our new note user interface. Okay, there's a connection between them. But I'm going to work towards this, and this is something I suggest often, is as cool as that visual designer is, it isn't a great place to do a ton of coding logic. I usually like to recommend sort of shifting that logic to another class. A class that you could call an engine class, often is the way it's expressed in gaming, or I'm going to call it my main controller class. This is kind of working off a kind of a programming paradigm. I know it's not really part of the IB, but there's this idea of things like model view controller and stuff like that, the MVC model. It's a bit older, it's a bit of a web-based one, but still it's a way to organize your code. So my main UI would be connected to my main controller through usage. Okay, it would use this main controller, and then the main controller would use the notes class. All right, so let's make some connections here now. So I connected this main controller to the notes class, but really I'm rethinking that idea because maybe we'll make a class where we can store our data structures that can be shared across our other classes. So maybe I'll just make a class called data structures. And maybe I'll connect the main controller to that class. And I'll reverse that, right? So the main, or no, sorry, I won't. The main controller will use data structures. The new note UI will use data structures. They'll be using that class. And the data structures class will be using the notes class. And the notes class uses the linked list and it uses the node, et cetera, et cetera, et cetera. So that's what I'm thinking, right? That's kind of how that will go. The new note UI will use a new note, right? So I'm going to have to sort of rearrange things here to get everything kind of laid out here so that these classes will be connected and the relationships will be established that I want for these classes to work here. Now, new note UI, what I think I'll do there is also to have a controller class for that to divert the logic. So I'm going to redivert this logic from there to there, and then the new note will use that. So just some usage going on there all around these classes. Let me try and make all these lines the same size here. I'm losing everything here. Let's try that. Make these all a little bit wider. Okay. So this is maybe we'll be able to see things a little bit clearer, right? So that the main UI uses a controller which controls data structures, which controls the collection of notes. The main controller would also obviously use the new note UI, like it would build a new note UI. That new note UI or user interface would then be controlled by a new note controller, which would use data structures, and it would use, let me connect it here. It would use a note, right? It would actually connect to a note as well, a new note. So here you can kind of see these connections. And it would also at some point be connected to a permanent file, but we don't really need to put all of that into our UML right now. This is a basic idea of a UML. Let me just space it out a little bit. So got the main UI connected to a controller, which connects to this, which connects to this, which connects to a note, connects to a bunch of notes, just to kind of place things, move things around here a little bit. Okay, so that would be my idea for a UML diagram. So I'm going to export that as a PNG, as a graphic. And I'm going to insert that into my written sections. Sorry, I just got to reopen these. So this would be for my appendix. So I had a figure 3. Let's make a figure 4. Okay, so figure 4 will be me inserting that document in there. Okay, so my section A, my section B, I've documented that I began examining the data structures and using a UML diagram. So I'm going to have that be seen in figure 4. So figure 4 of my appendix will have that in there. So let's go in here. Okay. All right, so insert picture from this device. Hopefully that downloaded that, oh, here we go, PNG, download. So that should be downloading to the downloads folder, I hope. So let's go to the downloads folder and we should be able to pick it up. There it is. And there it is. So looking good. Shrink that slightly to fit on the page. So shrink it more. There we go. All right, so we got a UML diagram now as part of our appendix. So that would be another nice piece of evidence to show the development of this solution and how the code is not, as you recall, the code is not, just one sec, place that back up on the project, on the screen here, yeah. So now we're trying to get to that high level of complexity, appropriate use of tools, and adequate for the task there. So we're kind of getting there. All right, so now we got to get down to work. We've got kind of a bigger plan now as to where we're going to go with this. You can see it in our appendix as well. That we've got some other classes to build. Okay, we've built some of these, but we got to build some more. We've got to build some stuff into this that will be part of this process. So now I can see that there's going to be something in my data, a class, so a new Java class for the, and I believe I called it data structures, right? So I'm going to make this class here. It'll be a place to store my data structures. Okay. So I'm going to make a data structures class. I'm going to make a note class, note, and a notes class. Okay, so you can see those here now. The data structures, the note, and the notes are part of my solution. Haven't coded them yet, but they're in there. I got my user interfaces. Maybe I need some controllers for those user interfaces. I could certainly put them in the same package. I think that might be appropriate. I could also make a package called controllers if I want. But, you know, we're getting a little out of it. So anyways, I'm going to make those. New Java class, the main controller, and the new note controller. Okay, so those are going to be my two controllers. Each of these will control the user interface. Just a slightly better way to code it so that we kind of are breaking what the user looks at and interacts with, separated from the logic that kind of does a lot of the heavy lifting. Okay, so that looks pretty good. But now I need some of the nitty-gritty stuff. I need some of those data structures that if I look at my UML, right? So I've got the note, the notes, I got the controllers, I've already built the user interfaces, and I built data structures. But what I'm talking about now is the linked list and the node class. Now these, you don't have to start from scratch. These are things that we've built in our IB Computer Science class. And if you're not one of my students, hopefully your teacher's done this as well. But if you're not one of my students and you want to access this stuff, I'm going to show you how to do it right now. So what I'm going to do right now is I'm going to go online, leave that, and I'll just start from scratch. I'm going to Google search Mr. Walks, and I'm going to go to my GitHub page. So Mr. Walks GitHub, okay, which is where I have code. So a quick Google search for Mr. Walks GitHub should get you there right away. From this GitHub page, I'm going to actually go to this repository here for the 42S IB, the IB repository, okay? Yes, there's a 20S, a 30S, a 40S, and those are got some good stuff in there too. But I'm going to specifically go to the IB repository, and I'm going to download this repository. So I'm going to click Code, Download Zip. I'm going to download the whole thing. Okay, if you are one of my students, you probably already have this big example. But then I'm going to take it and I'm going to unzip it because it comes in. I'm going to extract it and I'm just going to put the whole thing on my desktop for now. So I'm just going to put the whole shebang on my desktop. I might even put it in this internal assessment folder. So it's just going to go in there and extract it. So it's all going in there right now, that whole thing. So now in addition to my electronics notes project, I've got a bunch of code here that I could theoretically use. All right, so let's use it. So now what I'm going to do is from NetBeans, I'm going to open that project. It should be on my desktop in that folder, internal assessment, and there it is, the master branch of the computer science 42 SIB thing that I got live off the internet in front of you. Now it's open here in NetBeans, and I can open up all the packages, right? And I need to think now, what might I need in this project? Well, I might need collections, because in there is the linked list and the node class. Now it also includes other things like, so you can see stacks and queues and stuff. But I'm just going to grab that whole package called collections, and I literally dragged and dropped it over here to electronic notes. Okay, now that will end up breaking this up here. You can see here that's going to break that other project. But that's okay, I'm kind of done with, I don't need to use this project. I'm just taking from it. Now in addition, I might also need the IO package, because it's got a way to do file handling, so the saving and opening of files. So I'm going to take the entire IO package over as well, drag and drop it over. And I'm also going to take this tools package. Why tools? Because sitting in tools, again, if you know me from this course, is the ability to search and the ability to sort. And there's other things as well, but I'm just going to take all the tools over, okay? Now you can see I don't need any of these testing code here. I really don't need that stuff. So I'm going to right click on this and I'm going to delete it now. And I'm going to check off that it's going to delete the folder as well. Just click yes. So that was a real easy way for me to get a whole bunch of classes from the internet, from our in-class example that we've been working on. And now if you look in that folder on my desktop, you can see that that's still there, but it's basically deleted everything inside of it. So now I'm just going to finish it off and delete the rest of the folder. Because now all I got left is electronic notes, but now it's got access to all the stuff I might need. Now, I might by the end of this project end up deleting a bunch of these classes because I don't need binary trees and stacks and queues, but for now they're there. Similarly with my tools package, I don't necessarily need the calculator or images or numbers necessarily, but they're there for now. And same with the input output or the IO folder. The fact is though, I just saved myself a ton of time with that, and that will help us set up for the next part of this video where now we can start connecting these classes and start writing some of the logic. But for now, that's it for today. That's it for this part.